the ONNX Runtime. To start with, I'm going to start with our vision and mission statement, which is convert your model into ONNX, make sure it's run everywhere and optimally. In today's AI ecosystem, is very complex. And on one side, we have many frameworks that generate AI models, and we want to run those models on very diverse different targets with all kinds of hardware accelerators. And ONNX Runtime is a framework which will deploy a model on all kinds of platforms with all kinds of hardware accelerators, run them optimally. To start with, we define an open standard, which is ONNX. ONNX is the open standard for AI model representation, which is endorsed by major companies in the AI industry. This is other names. Those are all the sponsors of ONNX Runtime, part of ONNX community. And ONNX was, I think, started 2017 by Microsoft, Facebook, now named Meta, back then we call Facebook, plus Amazon, to try to establish open standard for AI models. They become a Linux Foundation project, and many companies since joined. All these companies here, not only they endorse ONNX, they all produce product that implement ONNX in their respective hardware. And the software, some companies are software companies, they also support ONNX. So once you get your model into ONNX Runtime will run it everywhere, as we promised. Now, how do you get your model into ONNX? So there's a number of open source converters for all the popular frameworks that will convert your models into ONNX format. And here are the list of open source converters. By the way, they are open source. And the more popular ones, like TensorFlow, PyTorch, they have very well-maintained converters. PyTorch converter is built-in, is part of PyTorch release. And if you get a PyTorch, you can export it to, once you use PyTorch to train your model, or have a model in PyTorch, you can export to ONNX within the PyTorch. Then there's other type of framework for like traditional machine learning, such as scikit-learn, CoreML, which are also very popular. Once you got your model into ONNX, we have ONNX runtime ecosystem, which will run your model optimally on all the target platforms and accelerate all kinds of hardware. With the help of ONNX community and ONNX, also the contribution from hardware vendors, we have a very thriving ONNX runtime ecosystem. Maybe I stand here. So first, here are list of the major some company that both internal from Microsoft and external companies, they actually authorized to advertise ONNX Runtime with their logos, endorse ONNX Runtime. And the first inside Microsoft, all the Microsoft products use ONNX Runtime as their inference engine. All your smart features in Microsoft product, they're all powered by ONNX Runtime. And externally, many major companies they name, here are the few names, and they are using ONNX Runtime to power their AI applications. At the bottom, you can see all the major hardware vendors. They work with us to add the support in ONNX Runtime for their respective hardware to make sure ONNX Runtime run optimally on those hardwares. So ONNX Runtime has, in today's AI world, it has a pretty long history, right? And so it's 6 years old now, almost. We started ONNX Runtime end of 2018. Back then, the name called Lotus RT was built for Windows operating system. And so the initial version, very first version, was based on the open source Cafe tool. For those people who still remember the old days of the AI world, and the Cafe tool used to be a popular open source software for AI framework. And there was this Lotus RT was released in April 2018 as part of Windows IS4 release. And as soon as we hit the code complete, I think towards the end of 2017, we started a complete rewrite of Lotus RT. And because after working with Windows, and we found a lot of limitation in the Cafe tool for scalability, extensibility, so therefore we did a complete rewrite, redesign ONNX Runtime. The new version of Lotus RT was shipped in the subsequent Windows release, IS5. And on the December of that year, Microsoft's marketing team officially named that they don't think flower name is fitting my, it's not very business-like. So they rename ONNX Runtime, give ONNX Runtime official name, ONNX Runtime. And we open sourced. So almost a year after, we reached 1.0 milestone, ORT. ONNX Runtime, we also call it ORT. And in this case, before that, there was two code base, ONNX Runtime, and the Windows actually take the ONNX Runtime code base, rebuild it with their own modification to ship with Windows. The ONNX Runtime 1.0 release, we finally merged the unified the two code base. Windows become part of execution providers, which I mentioned that what is execution provider of ONNX Runtime. Now, every window in the world is running ONNX Runtime, as you see in the open source GitHub repo. So in 2020 May, ONNX Runtime initially was built only for inference. In 2020 May, we released a training version. So ONNX Runtime now also can do training. And in 2021, June, we released ONNX Runtime mobile and web. Now we cover almost all the platforms, from your cloud server to a desktop, to mobile device, to a web browser. You can also run ONNX Runtime. So here is the ONNX Runtime high-level architecture. It's a very extensible architecture. So the idea is these execution providers, we call it EPs. Execution provider is a plugin framework, allow all the hardware vendors to implement their hardware specific acceleration as a plugin into ONNX Runtime. So we have dozens of companies around the world contribute to us to make ONNX Runtime running optimally on their hardware through these execution providers. To name a few, we have a CPU DirectML, which is for Windows. And NVIDIA has two, CUDA and TensorRT. AMD has actually two. We only need, there's MyGraph, and we only need here is Rackham, and Qualcomm and many others. They contribute their own software to make ONNX Runtime running optimally on their hardware. If your machine has their hardware, you can use ONNX Runtime to take advantage of the hardware. So this architecture also allows hardware. So the way it works, so you okay, step back, I think. Okay, see, I'm gonna stay here, probably better. Okay, yeah. I did see this one. Okay. All right, this is better. So we start with the ONNX model, and once we load the model into memory, and we do graph optimization, try to optimize the graph to simplify, to do some constant foldings, to do fusions, and then we have this graph partitioner. Graph partitioner will ask all the execution providers, query them what kind of kernel, which part of graph you can execute, you can accelerate. Based on the response from all the different execution providers, the graph partition will partition the graph, assign the loads to those EPs, which we think will do best for running these models. So then we have execute also a graph runner named graph runner, which will run this graph based on the graph partition. And ONNX Runtime provide a default CPU execution provider, which is one of the best CPU execution provider for the AI models. We use our own technology called ONNX, which is one of the top performance math libraries for perform AI model computation on both Intel and ARM CPUs. So with this architecture, each vendor only need to implement a few kernel. The kernel they think they can do best with their hardware. They don't have to implement full function to support all the kernels required for running these models. You can see this is a very extensible, also very good architecture for hardware vendor. They can easily get their hardware to accelerate the model, because for each model, it's like a program. There's an inner loop. A lot of model nodes in the model which does not take much time. Only a few nodes take most of the computation time. So if you're a hardware vendor, you don't have to implement everything. You only need to implement the accelerator for those few inner loop nodes. You can get the best out of this ONNX Runtime. to run your model effectively on these nodes. And you also can support larger number of models because ONNX Runtime already support probably tens of thousands of models, all kinds of models. So with support with our community and the hardware vendor, we have built really pretty comprehensive coverage for running AI model on different platforms. Here's the platform, architecture, languages, and the hardware we cover. For inference, we have Windows, Linux, Mac, Android, iOS, your web browser. ONNX Runtime will run this. And we also provide API for all the popular languages. These are our official supported. There's many our official API supported by third-party people, and a lot of this here. And for architecture, we support Intel and ARM, and also power, IBM power chips. Right now, as we speak, we also have a PR from Sci5, which support RISC-V processors. It's under review. So pretty soon you will also support RISC-V processors. And for the hardwares, so besides the default CPU, you see there's many execution providers from vendors, hardware vendor around the world. And we also, by the way, we also have these Azure EPs, which allow you to use Azure computer. If you have a model running on your client side and you don't have enough power, you can use Azure EP and set up an Azure service to run part of the model or entire model on the cloud to get the performance meeting your application criteria. The bottom part, we also have the training features, and we support all the major platforms. And the training function has two scenarios. One is for the large model training. The other part is on-device training. You can do training on your device, on your mobile phone, and on your web browser, on your desktop. Today we'll have give some talk, give a detail how you use ONNX on-device training. So I'm going to give a couple of highlights for ONNX Runtime application recently published as a blog, and it's publicly available. You can access the link, get the detail. The first one is on the large language model optimization. Large language model, you probably know, it's become very popular nowadays because the OpenAI, ChatGPT, ONNX Runtime, of course, it's best framework for running large language model, give you best performance. Today I'm not going to go to detail here because we're going to have a talk from Conan here to give you a very detailed deep dive on how to achieve best performance on large language model with ONNX Runtime. The next is also a recent Microsoft research blog, which talk about how you take advantage of ONNX Runtime and its run everywhere capability to do hybrid inference. The use case is Microsoft Editor Neural Grammar Checker. If you use Microsoft Office product, you know there's grammar check, and which is very useful features. And it's powered by an AI model called Neural Grammar Check. And traditionally, this is running on cloud, and it costs money. Also, it has limitation because you have to use, you have connection, internet connection. And so with ONNX Runtime, they were able to run this model. They switch to ONNX, they run this model on the client side. And if your client have enough computational power and memory, and other client, your desktop, your phone, your browser, as long as you have enough computational power required, this is running on cloud, client side. So for it, not only save the cost, is zero, right? Cost to serve this model because it uses users' own hardware, and it's also improve the usability because you don't have to have a network connection to use these features. And for the people don't have enough computation power on their device, is still on the server side. With ONNX runtime on the server side, they were able to get 2x inference speed up, 3x cost reduction, 7 cost reduction for the grammar neural grammar check. The detail you can see in this plot. Oh, I almost running out of time. So I'm going to be very quick, go through this. So I'm going to highlight a few things. So there are 3 major versions of ONNX runtime to cover all the platforms. With your regular ONNX runtime, which is the 4 build, we're running on your server and on the desktop computers. And then we have a version for browser, running on your browser. And we also have a version running on your mobile device called ORT mobile. One of, I think, very nice engineer achievement for ONNX runtime is that all our 3 major versions of ONNX runtime are built from the same C++ source code. Therefore, they can run the same ONNX model, and they can support exactly the same model they run. And so it's truly one model run everywhere. Like even for the web browser, because web browser, you need a JavaScript. And the way we achieve same code base for the browser, we use compiler to compile C++ code into WebAssembly. WebAssembly is a bytecode for JavaScript engine, and it is actually faster than JavaScript. So therefore, we were able to run the model in browser with the same functionality as the 4 version of ONNX runtime. So in addition to the CPU, lately so the CPU is running with WebAssembly EP, and we have this, I'm going to speed up, highlight the biggest thing come up is this Web GPT EP. This is the latest web standards to allow people running browser app using GPU on your local machine. So it gives us 10 to 20 times speed up over the WebAssembly. The latest release, ONNX runtime 1.17 just released, we have a full support of web GPU, which is very big, very popular for our community. And if you doing the web application, you probably know transformer.js from Hugging Face, where they have almost, I think it's hundreds model from Hugging Face running on the web browser, which is powered by ORT web. So the web A, I'm going to skip. The other part is ONNX Runtime Mobile, which is same code base, and which specifically targeted for running a mobile application. In this ORT Mobile, we also make your life easier to add in the pre-post processing. Because if you deal with AI model, you know all the AI framework talk to AI model with this thing called tensors, which is gigantic n-dimension matrix. And your application typically don't talk tensors. You it's a language, or you have a picture, you have an image file. So therefore, there's a lot of work to adapt your application to run in this AI model. There's a lot of work, and especially for mobile and web applications, it is very difficult to program those kind of features. So we developed something called ONNX extension, which extend the ONNX graph to cover pre-post processing. We have all the pre-built operators for all popular pre-post processing. All you need to do is to expand your graph to include these pre-post processing loads, and you're ready to go. So it's very easy for you to do this. And we will have engineer Wenbin going to talk about our next runtime extension. There's some new feature come up. I'm going to skip this. The other part I want to briefly mention that we have this new feature on device training that allow you can train your model on the device. And the application scenario, for example, if you want to fine tune your model, and you can use your local data to fine tune your model with ONNX runtime. This is especially useful for nowadays because of privacy issue. People don't want to upload your data to the cloud. And this way you can do it. The other part is federated learning. And you can train your data, train on your local device with the data that contribute the gradient to some server. And globally, you achieve you can a better model through learning from all those devices. There's many application has been building around this. And so I'm going to skip this due to time issue. So there's a few things I want to advertise going to come up. One is the ORT Gene API, Gene AI API. This is an API specially designed for people interested in doing generative AI, and the ONNX runtime will provide this high-level API, make it easy to program, easy to customize the model for your application. The next big thing is this new PyTorch Dynamo export, which will give us a bad fidelity and running quicker and take less memory. And right now it's in beta, it's going to come up very soon. That's all I have. Thank you very much. I think we leave question to the end. Or
We can do a quick question if there is any.
Yeah, any question? So I'll be here at the end to answer your question if you want to leave your question at the end of the seminars. All right, thanks everyone.
Thank you, Yue-Sheng. That was Yue-Sheng, and he gave us an overview of the ONNX runtime. Next, we'll have Kunal.